electromagnetic waves and the electromagnetic spectrum. The first slide of our slideshow, you'll recall, showed us parts of a wave. You should know the crest is the highest point of the wave, the trough is the lowest point, and the distance between two successive crests or troughs is called the wavelength. Frequency refers to the number of wavelengths that pass a given point in 1 second, and it's measured in a unit called hertz. So the closer the wavelengths are together for light, since all light travels the same speed, the higher the frequency. The longer the wavelength, the lower the frequency. So as the wavelength increases, the frequency decreases because fewer crests would pass a given point in a certain amount of time, like a second. The electromagnetic spectrum is organized according to wavelength and frequency of waves. It represents the distribution of different electromagnetic radiation. And so if we take a look at the electromagnetic spectrum here, I'll move this out of the way again. You can see that the longer wavelengths on this one are on the left, and those are radio waves. And as we get shorter, we're getting to more energy in the wave. So if you think of what oscillation has to occur to cause this wave to go up and down, you need more and more per second as you move to the right. And so you go low energy to high energy from the left to the right on this diagram. Long wavelength to short wavelength. And you can see the different waves are labeled on this diagram, as well as they show different objects that would be about the same length as one wavelength. There are two main categories of waves, mechanical and electromagnetic. Mechanical waves, recall, need to transfer through matter, which we call a medium. Examples of mechanical waves are waves that you would see in water, sound waves, and seismic waves through the ground. Electromagnetic waves are able to transfer energy through space. We call it field. They don't require a medium with which to travel, so the vacuum of space they can travel. Examples are all forms of light. This refers to probably visible light, radio waves, ultraviolet, and X-rays. All parts of the electromagnetic spectrum are considered electromagnetic waves. So let's take a quick look at electromagnetic waves. They are different from mechanical waves in that they do not require any atoms to move through. The two main sources are stars, like the sun, as well as human technology. EM waves do not need a medium or a substance to travel through. They're able to travel through the vacuum of space. They all travel the same speed, which is the speed of light, 300,000 kilometers per second in a vacuum. They all have the same amplitude, but different wavelengths and frequencies. And they're organized by their unique frequencies on the electromagnetic spectrum. They all travel at the speed of light. So some examples of the speed of light here. How long it would take light to go from Burnsville High School to different objects. So then we took a quick look at the electromagnetic spectrum itself. The EM spectrum is a family of electromagnetic waves that we have, as humans, have classified into 7 groups. And they're based on the amount of energy that they carry. So long wavelengths are low energy, short wavelengths are high. We start with the longest wavelengths. These are radio waves, followed by microwaves, infrared, visible light, ultraviolet, X-rays, and finally gamma rays. Taking a look at each of these more closely, we see that if we arrange them from high energy to low energy here, they go in this order. And so the shorter wavelength have the most energy, and the longer wavelength have the least amount of energy. So let's start with radio waves. They have the longest wavelengths and the lowest frequencies and the lowest energies. They travel easily through the atmosphere and other materials. And the uses of these are AM/FM radio, TV remotes, garage door openers, alarm systems, and baby monitors all use radio waves. Radio and television uses radio waves to transmit information. They send out waves that carry sound and visual information in them, and those get transmitted to a radio or a TV. Radio waves can carry information in different ways. AM radio changes the amplitude to encode sound. FM radio changes the frequency. AM actually stands for amplitude modulation, and FM stands for frequency modulation. And TV uses AM waves for the picture and FM waves for sound. The next step is microwaves, a little bit shorter wavelength than radio waves and a little bit higher frequency and energy. These easily travel through the atmosphere and through many other materials. The uses of microwaves are microwave ovens, cell phones, radar, and satellite communications. Radar is an acronym that stands for Radio Detection and Ranging, and it detects objects by sending out microwaves and receiving the reflected waves to form a picture on a screen, so they can locate objects. Doppler radar is actually measuring the movement of something, the Doppler effect. And so Doppler radar can be used to detect incoming weather, storms, and so on. Your phone is a microwave transmitter and receiver. They use overlapping networks called cells, each with a tower in its center that receives and transmits microwaves. So in a local area, you might have a lot of overlapping cell towers so that you're able to communicate instantly with people in other areas. Microwaves heat up food from the inside. What happens is the microwaves actually cause the water molecules in the food to vibrate, and that causes friction and causes them to heat up. The heating properties of microwaves was discovered when a radar analyst's candy bar melted in his pocket while working. The next stop is infrared. Infrared waves are often associated with heat. They are produced when a warm object radiates heat. They can't be seen by us, but they can be felt, and we use those in some remote controls. Thermographs, which are images that show different heat signatures, and heat sensing animals. So it is visible to some organisms. Pit vipers have special pits on their heads that they can detect heat from their prey. This includes rattlesnakes, cottonmouth, copperhead. Infrared light is visible to some organisms, and so they might see a dog, something like that. We also have infrared cameras that are used in medicine that can tell differences in temperatures. These are called thermographs. So let's move on to visible light. Visible light is the type of light that we can see with our eyes. It's a very narrow portion of the electromagnetic spectrum. Special cells in our eyes called cones allow us to detect color. And visible light only makes up a very small portion, like I said. We can remember the colors of visible light by an acronym, ROY-G-BIV, and that would be red, orange, yellow. G is green, blue, indigo, and violet. The lower frequency, the longer wavelength are red light, and violet have the higher frequency, more energy, shorter wavelengths. Moving on to ultraviolet. Ultraviolet rays occur naturally in sunlight. They reach the earth, but most are absorbed by a layer in the atmosphere called the ozone layer. Ultraviolet light can be dangerous because they can cause skin cancer and cataracts and sunburns. We use ultraviolet light for sterilizing water and medical equipment. In fact, the goggles in this room use ultraviolet light to sterilize them between uses. It is visible to some insects. Bees and other insects can detect the higher frequencies of ultraviolet light. Our next stop is X-rays. X-rays have very high frequencies and energy. They can penetrate most substances, including human tissues. So we use those to view bones inside the human body, teeth, and so on. Finally, gamma rays are the shortest wavelengths. They carry the most energy. They're produced by stars and some radioactive materials on Earth and can penetrate all human tissues, killing cells, and they can cause cells to mutate, which creates cancer cells. They can be used in fighting tumors by killing off the cells. Black holes emit energy in the form of these gamma ray bursts, and certain cancers can be treated using gamma rays. So again, radio waves are about the size of a building or larger, microwaves about the size of a person, infrared waves you can think of the size of a bee, visible light is very small, ultraviolet the size of bacteria, X-rays the size of atoms, and gamma rays are the size of atomic nuclei. Okay, so from that we did the electromagnetic spectrum worksheet. You should have received that back if you handed it in on time. Make sure you review that before the test. We watched the ED puzzle, tour of the electromagnetic spectrum, and this is the Incredible Hulk. We don't need to watch that right now. Then we watched Cosmos Hiding in the Light, about the discovery of spectral lines. And then finally, we did the Whodunit, which had you review the properties of light on the electromagnetic spectrum by doing different multiple choice questions around the room. Okay, any questions? Make sure you ask. You should be ready to take the quiz.